Alright, in this video we're going to do a bit of reviewing on polynomials, some definitions of polynomials, and we'll also look at some operations. To begin with, a definition of a polynomial would be any kind of an expression where you have a variable, an x, and that x can be raised to any kind of a power. And there's also, with a polynomial, there's, I guess, three parts to each term. We'll talk about those in a minute too, though. But you have a number part, a letter part, and an exponent part. So this is sort of the general format for it, where they have x to the n, and then the next x would be one number less than what that one was. So like if this one's a 3, then typically your next term would have a 2, next term would have a 1, not one written there. And this one you could write it as x to the 0 if you wanted to. So they all would have x's, but this x to the 0, anything to the 0 power is 1, so we typically don't write it. Okay, so this is sort of a fancy kind of definition, but this is really what we're talking about. An expression that has some x's and numbers and exponents in it. Okay, so when we're looking at a term of a polynomial, and we use that to help differentiate what kinds of terms we have, but a term of a polynomial is separated by either an addition sign or a subtraction sign. So if I look at this polynomial expression here, it's got 4 terms. There's one term there. Here's an add or a subtract, so that separates this term from this term. A subtract separates this one from this term. Another subtract separates that. So in this term here, it's a 4-term polynomial. I guess you could call it a quadrinomial. We'll just call it polynomial for now. Also, another way of expressing or describing a polynomial is looking at something called a degree. And a degree refers to what the exponent is, basically. So you can talk about the degree of a whole polynomial, but you can also talk about the degree of each individual term of a polynomial, and we'll look at that in a second. The degree of a whole polynomial you just find by finding what the highest exponent is. So here I have a 12, here I have a 15, here I have a 1, and this one would be x to the 0, so it would be 0. Highest degree is this 15, so this polynomial here would be of degree 15. Knowing what degree it is helps me know what kind of graph that this thing might look like, and we'll talk about that in another lesson. Now, if you have multiple letters in a term, here's a term, here's a term, here's a term, here's a term, so 4 terms. If you have more than one letter there, like an x or y, p, q, whatever, to find out what the degree of this term is, you add those two exponents. So x squared, y squared, so this 2 plus 2, this would have a degree 4, that term. This one here, there's a 1 here plus 2, this would be a degree 3. This one here would be 1, 2, 3, 4. This one would be 1, 2, 3. So this polynomial, since I have each of these written with a 4 of a degree, the whole polynomial would have a degree of 4. Okay, so that sort of helps you determine what the degree of each term would be. Now, once we've got some polynomials, now we want to do some operations with them. So in this one, we're going to look at some adding, subtracting, and multiplying. That'll be the rest of this video. So if you're adding polynomials, you're looking for like terms. Like if I have an xy squared and an x squared y, they're not exactly the same because the variables, I guess I have the same variable, but their exponents aren't the same. So I have to have identical letters and identical exponents to be a like term. If I am adding this big term here with this big term here, if I'm adding, what I can first do is just drop the brackets. I don't need to use brackets there because I'm adding. Plus 6, okay, plus a negative xy squared minus 5x squared y plus 8xy plus 4. So here I drop the brackets. Now I can look for like terms. So here I have an xy squared. Is there another one? Here's one right there. So I have 2 and I lose 1, so I'd have 1 xy squared. Okay, now I have an x squared y here and an x squared y there. Here I'm down 4, I lose another 5, so I'd be down 9 x squared y. And then here I have an xy, here's an xy, down 2, gain 8, so I'd be up 6xy. And lastly, I've just got some plain numbers, a 6 and a plus 4, so that would be plus 10. So to simplify this, or to add these two polynomials, this is what I'd get. Notice that I used colors here. If you have some extra pens or different colors, sometimes that helps you just sort of organize how you're doing things. So that's adding. Now let's try some subtracting. When I have a negative sign in front of a bracket, I have to be careful. By far the mistakes in math courses that I've seen, the subtraction in front of a bracket or in front of some kind of an expression is by far the most likely of errors to happen. A student called that error a dirty, rotten, filthy, stinking negative, and if that helps you remember to be careful with that, remember that sort of funny phrase, dirty, rotten, filthy, stinking negative. So what you have to do is you have to add the inverse of the second bracket. So what that means is drop brackets, 4x squared minus 5x minus x cubed plus 9. Okay, add the inverse of the second bracket. So change this to an add, and then change the sign of every term in the second bracket. So this is negative 2, it changes to a positive 2. Negative 9x changes to a positive 9x. Minus 9x, 4x cubed changes to a positive 4x cubed. And lastly, a positive 8 changes to a minus 8. Let me just check. That changes to a positive, 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 negative. So every term changes. Now you do just exactly what we did before. 4x squared, 2x squared, that would be 6x squared. Minus 5x plus 9x would be a plus 4x. And then minus x cubed plus 4x cubed would be plus 3x cubed. And lastly, a plus 9 minus 8 would be plus 1. Okay, so subtracting is really the same as adding. There's just this one little step that you have to do first before you can collect like terms. Okay, so that's adding and subtracting polynomials. Let's try some multiplying. We'll multiply monomials together, then we'll do some binomials, and we'll look at some special cases too. So a monomial just means I have one term. So one term here, one term there, and I'm multiplying. When I multiply, you have to keep three things for me in mind at all time. And this doesn't stand for Saturday Night Live. It stands for signs, numbers, and letters. So when I'm multiplying these, I always do those three things. So 4 times a minus 8, it's a minus, so my answer is going to be a minus. 4 times 8, there's my numbers, that's 32. And then I deal with the letters. So x squared times x to the 5th, multiplying common bases, add their exponents, so that'd be a 7. So negative 32 x to the 7th. Similarly over here, both are positive, so it's going to be positive. Oops. 3 times 5 is 15. There's my number part. And now let's deal with the letters. m6 times m squared would be m to the 8th. n times n 7th would be n to the 8th as well. So that's multiplying monomials. Let's try somewhere we're multiplying more than that. So here's a monomial multiplied by a binomial. When you multiply polynomials that are bi or trinomials, you've got to use the distributive property. So for this first one, I use the distributive property once, where I'll take the 5 and multiply it by the x, and I'll multiply it by the 3. In this one here, I've got to use the distributive property twice. So I've got to multiply this by this, and then this one by that one, and then this one by this one, and this one by that one. So I'm taking this and multiplying by both things over there, that's once. Then take this and multiply by both things in the second bracket, that's twice. So for the answer for this one, and again, every time you do one of these arcs or multiply this, you've got to think of sign, number, and letter. So 5 times x is positive, the number is 5, the letter's x. And then 5 times a negative 3, negative 15. Let's do this one. Negative 2m times 3m would be a negative, there's my sign, number, 2 times 3 is 6. Letters, m times m would be m squared. Okay, now this next one would be negative 2m times negative 5. The sign will be positive. 2 times 5 is 10, and there's only one m there. And then this one, 4 times 3m is going to be positive. 4 times 3 is 12, and there's just one m. And then lastly, 4 times negative 5, negative 20. When I've got this one here, when I'm multiplying a binomial times a binomial, often these two middle terms are like, so I need to collect those just as a final step. So my answer for this would be negative 6m squared plus 22m minus 20. Okay, so that's a binomial times a binomial. Here's one, and well, maybe I'll do it. But it's a binomial times a trinomial. So this time I'll have to multiply this by that one, and by that one, and by that one. And then I have to do the same thing with the y on the bottom. Maybe pause and try it on your own, and then see if you press play and see if you can get the same answers I have. Okay, hopefully you've pressed play again. So this times this would be 3x to the 5th. This times this would be a negative x squared y. This times this is a negative 5xy to the 4th. And then the next one, this times this would be a negative 3x to the 4y. This times this would be a positive xy squared. And this times this would be a positive 5y to the 5th. Now, any like terms? This is an x to the 5th? No. X squared y. No. No, they're all different terms, so that would be my answer to that question. Now, that's some multiplication. And it turns out that there are some special cases that sometimes happen, like if I have two binomials that are the same. So say I have x plus 2 times x plus 2. When I'm multiplying those, something sort of fancy comes up. You don't have to worry about memorizing these, but let me just show you what happens. So x times x would be x squared. X times 2 would be a 2x. 2 times x would be 2x. And lastly, 2 times 2 would be 4. So when I write those together, when I simplify that, that would be 4x plus 4. What happens is that when you multiply them, if you see a binomial squared like this, you could just write the first one squared, the last one squared, and then 2 times whatever this times this comes out to. Does that make sense? In other words, so this times this, that gives me my x squared. 2 times 2, that gives me the 4. And then I go, x times 2 is 2x, and I times that by 2. And that's how I can get the 4x. It's sort of a shortcut. For me, it doesn't work. I just like to multiply it out using FOIL, just like you always do, and I don't have to remember an extra rule. That's the same thing with this one. You can do the same thing. Now, with this last one, you can do this one, but this is a nice one to be able to recognize. And it's called the difference of squares. Let me do one of those. I guess when you go the other way, it's called the difference of squares. But here I'm multiplying two binomials, and they're conjugates of each other. Or in other words, one has a plus and one has a minus. Watch what happens when we multiply those. 8 times 8 is 64. 8 times negative x would be a negative 8x. X times 8 would be a positive 8x. And lastly, x times negative x would be negative x squared. When I collect these like terms in the middle, negative x plus, they cancel each other out. So I'm left with 64 minus x squared. And every time, if you take a binomial or two binomials where one is the conjugate of the other, in other words, the sign in the middle is different, this happens every time. Here's another example. Let me multiply it out. 4x squared plus 10xy minus 10xy minus 25y squared. Notice these two in the middle, positive 10, negative 10, cancel out. my answer for that product would be 4x squared minus 25y squared. This here, when we get into factoring in the next section, this here, when we look at this and they ask us to factor it, we'll call this a difference of squares, because it's a difference of two squares. And you get these when you're multiplying two conjugates together like that. Okay, just one last one. Here's one where we have to multiply a bunch of stuff together, just as a little practice thing. So I've got I've got three binomials here that I have to multiply together. Easiest way is to multiply one or two of them together and then take the answer to that and multiply it by the last one. So I'll do that. X times x, x squared, x times negative 2, negative 2x, 2 times x, positive 2x, and 2 times negative 2 is negative 4. Notice that's a sum and difference. So what's going to happen in here is these two middle ones will cancel, which is nice. So that's what I get when I multiply the first two terms together, or the first two brackets together. But I had to remember that I still have that sitting over there. Now I've got two more binomials that I can multiply together. So x squared times x squared, x to the fourth. X squared times 1 would be a positive x squared. Negative 4 times x squared is negative 4x squared. Lastly, negative 4 times 1 is negative 4. Like terms in the middle, so this would be x to the fourth minus 3x squared minus 4. Okay, so if I multiply that out, this is the product that I get. So that's some introductions to some definitions of polynomials and looking at a few operations from your textbook. Here's some questions that you can do if you're not using the same text as us. Find some where you do some operations with polynomials.